Welcome to Module 7. Welcome to Module 7 of the Python programming course using Python for data analysis. In this module, we will explore the core libraries and techniques that make Python the world's leading language for data analysis. NumPy, Pandas, Matplotlib library, and Seaborn. What you will learn. This module covers 6 key topics. We'll begin with NumPy for numerical computing, followed by Pandas for data manipulation and data frames. We will then cover data cleaning and preparation, reading CSV and Excel files, statistical analysis, and finally data visualization using Matplotlib and Seaborn. Introduction. Data analysis has become one of the most important applications of Python programming. Organizations across every sector, finance, healthcare, retail, government, and research generate vast quantities of data daily. The ability to collect, clean, analyze, and visualize this data is critical professional skill in the modern economy. Python data analysis ecosystem is centered on 3 core libraries. NumPy provides the numerical computing foundation, while Pandas build on NumPy to provide data frame structure for working with structured data, and Matplotlib library together with Seaborn provide comprehensive visualization tools. Together, these libraries form the complete data analyst toolkits. The key takeaway is this: Python is the world's #1 language for data analysis, and NumPy, Pandas, and Matplotlib library form the essential foundation of that capability. NumPy provides the end array, a fast memory efficient n-dimensional array that is approximately 50 times faster than standard Python list for numerical operation. It serves as the foundation of all Python data science libraries. In the first example, we create 2 arrays and perform element-wise arithmetic without the need for explicit loops. We also demonstrate built-in statistical functions such as mean, median, standard deviation, minimum, and maximum. For example, this is the example that demonstrates 2D arrays and useful function. Import NumPy as NP, creating the array. So this is how you can create the array. That is, for example, array1 is equals to np.array, open parentheses, square bracket 10, 20, 30, 40, 50. Close the square bracket, then close the parentheses. Array2 equals to np.array, open brackets, square brackets, 1, 2, 3, 4, 5, close the square bracket and close the parentheses. So this is the example of how you can create array. The second line is for element-wise arithmetic, and that is how you can create the element-wise arithmetic. That is no loop needed. Then for statistical functions, that is how you can create it. For 2D array, that is matrix, that is how you can also create it. If you want to create the matrix, then that's how you can do it. For usable array creation function, also that's how you can create it. For Boolean index filtering, that is also how you can create it. And for array operation also, that's how you can create it. By following the examples, you will also learn how to create the array using NumPy function. NumPy also supports 2-dimensional arrays or matrices. We can access rows and columns using indexing notation. Array creation functions such as zeros, ones, arrange, and line space are frequently used to generate structured numerical data. Boolean indexing also allows us to filter array values based on condition. For example, selecting only scores that are 60 or above. Additionally, operations such as sort, cumulative sum, and percentile calculation are also demonstrated. Pandas. Pandas data frames for structure data. Pandas is a primary library for working with structure tabular data in Python. It calls data structure is the data frame, essentially a table with labeled rows and columns, similar to a spreadsheet. In the first example, we create a data frame from a Python dictionary and use basic exploration method. Heads to view the first row, shape to check dimension, D types to inspect column types, describe for statistical summaries, and info for non-null count. We also demonstrated how to access individual columns, multiple columns, specific rows by position, and filter to row by condition. So this is the example that demonstrates that for creating and exploring data frames. These are the examples that demonstrate that. For filtering, grouping, and aggregation. So this is the example for you to do that. That is the first one is for filtering row. For sorting, that is it. For adding new columns, and for grouping and aggregation, that is it. So by following the demonstrated example, you will also learn how to do that. Then continuation. Pandas also support filtering rows by condition, sorting by columns value, and adding new computed columns. The apply method also allows to pass function, including a lambda to each row or column value. The group by method is used to group data by categorically column and compute aggregate statistics such as mean, count, maximum, and minimum per group. Pivot table provide a convenient summary of group of data. So data cleaning, preparing real-world data. So real-world data is rarely clean. The four most common issues are missing values represented as none or none, duplicate rows that inflate counts, columns with incorrect data types such as numbers stored as strings, and inconsistent text formatting such as the same city name written in different cases. The cleaning process shown here follows 6 steps. First, we check for missing values using its null.sum function. Second, we fill missing numeric value with the column, meaning using fill na function. Third, we drop rows where a required field such as name is absent. Fourth, we remove duplicate record. Fifth, we standardize text using str.title function and str.strip function. Six, we correct data type using pd.to_numeric function. And for you to do that, that is how this example demonstrates on how to find the missing value, duplicate rows, to find wrong data types and inconsistent text. So that's how you can find it. Reading CSV and Excel file with pandas. One of the most powerful features is its ability to read data directly from CSV and Excel file. The read_CSV function loads a CSV file into a data frame. Optional parameters allow us to specify the delimiter, header row, index column, which columns to load, how many rows to read, and the file encoding. Similarly, read_Excel load data from an Excel file with the option to specify a sheet name or load all sheet at once into a dictionary of data frames. Both functions have corresponding to_CSV function and to_Excel method for saving clean data back to file. So this example demonstrates how you can import CSV file or how you can import Excel file operation. Statistical analysis with Python. Statistical analysis is a fundamental step in any data analysis workflow. The key descriptive statistics are mean, the average value, median, the middle value when data is sorted, mode, the most frequently occurring value, standard deviation, the separate values around the mean, variance, the square of the standard deviation, and the correlation, a measure of the relationship between two columns. In the example below, we compute all these statistics on a pandas series of student score. We also calculate the 25 and 75 percentile. Finally, we compute the correlation matrix between student hours and score, which reveal a strong positive relationship between the two variables. So by following the examples, you will also understand. It is straightforward example. Data visualization with matplot library. Matplotlib is a Python primary charting library and supports 6 core chart types: bar chart for comparing categories, line chart for showing trend over time, pie chart for proportion, scatter plot for relationship, histogram for distribution, and box plot for showing spread and outliers. In the bar chart example, we plot average score per model using plots.bar. Add a title, axis label, set axis limits, and save the chart to a file using savepgo function. The line chart add markers at each data point and uses fill.between function to shade the area under the line. The scatter plot visualizes the relationship between the study hours and scores. So this is the example that demonstrates the data visualization with matplot. By following the example, you will also understand how it has been done. And if you run it, you will surely see how it has been, the bar chart has been plot. All the functions are demonstrated in the example. Advanced visualization with Seaborn. Seaborn is a build on top of matplotlib and provide beautiful statistical chart with significantly less code. It is especially suited for distribution, correlation, and categorically data visualization. The first Seaborn example create a histogram with KDE curve, which stand for kernel density estimate, to show the shape of the score distribution. The second example create a box plot to compare score distribution across 3 modules, clearly showing the median, interquartile range, and outliers. The third example produce a heat map of correlation matrix using color intensity to indicate the strength of relationship, and that is the example. This example demonstrates a complete 5-step data analysis workflow using pandas and Seaborn. We load CSV file, explore it, clean it by removing nulls and duplicate, compute the average score per model using group by, and finally produce a 2-panel figure, a bar chart on the left showing average score per model, and a histogram with KDE on the right showing the overall score distribution. The figure is saved to PNG file for reporting. Complete data analysis project, student performance. This slide presents an end-to-end data analysis project on student performance data, integrating all the tools covered in this model across 5 steps. Step 1, load the CSV file and print basic information. Step 2, clean the data by converting the score column to numeric, dropping rows with missing scores, and removing duplicate. Step 3, enrich the data set by applying a grade assignment function and a pass/fail classification using apply. Step 4, perform analysis computing the class average, highest score, and pass rate. Step 5, produce a 3-panel figure, a bar chart of grade distribution, a histogram of score distribution, and a pie chart of the past rate. So this is the example. Do's and don'ts Python data analysis. This slide summarizes best practices and common mistakes in Python data analysis. You should always explore the data first with head, info, describe. Always check for missing values before analysis. Use pd.dot underscore numeric, open parenthesis, errors equals to cost, close the parentheses, to handle bad data types. Use drop open underscore duplicate function to clean repeated record. Add titles, exit levels, and legend to all chart. Use plt.tight underscore layout function to prevent chart element overlap. Save figures with plt.save figure function before plt.show function. Use virtual environment with pin library version. Document your analysis step with comments. Don't avoid. Don't skip data cleaning. Dirty data is equals to wrong result. Don't assume data is clean just because it loads without errors. Don't use pill Pilna function without understanding why data is missing. Don't create chart without title and axis levels. Don't use pie chart for more than 5 categories. Don't confuse correlation with causation. Don't ignore outliers. Investigate them first. Don't hardcore file fast. Use relative paths or os.fast. Don't analyze a sample when you need the full data set. Data analysis ecosystem summary. Let us summarize the complete Python data analysis toolkit covered in this model. NumPy provide n-dimensional array that are 50 times faster than Python list, mathematically function and serve as a foundation for all other data libraries. Pandas provide the data frame and series structure for filtering, grouping, and aggregating data, as well as tools for reading and writing CSV and Excel files and comprehensive data cleaning capabilities. Matplotlib handles all core chart types, including bar, line, and scatter plot, support full customization, and can save chart to PNG or PDF format. Seaborn provide beautiful statistical charts such as histogram with KDE, box plots, and heat map, all built on top of Matplotlib. SciPy extends the ecosystem with statistical tests, regression analysis, and scientific computing. Jupyter Notebook provide an iterative environment for mixing code, narrative text, and inline chart, the standard tool in professional data science. Conclusion. This model has provided a comprehensive introduction to Python-based data analysis. NumPy has been established as the backbone of numerical computing, providing efficient array structure and mathematical operation. Pandas has been demonstrated as the primary tool for structured data manipulation, with data frames enabling filtering, aggregation, and transformation operation central to analytical flows. Data cleaning has been addressed as one of the most time-consuming but critical steps in real-world analysis. Matplotlib and Seaborn have been provided the tools to transform, clean, analyze data into meaningful visualization. The complete analysis project demonstrated how all these tools work together in professional workflow. Key takeaway: data is the new oil, and Python with NumPy, Pandas, and Matplotlib is the refinery that turn raw data into insight.